Thank you, Mike. And since I couldn't be in Japan, I was invited, and I'm sorry I was not there. I decided to simply dress up for my event with you. The history at Google is that we have ridden a series of amazing waves. And obviously the mobile phone wave with Android and smart computing really has transfixed our company and all of you. And by the way, with leadership starting in Japan years ago. And I'm now convinced that that next wave is going to be machine learning. So what I wanted to do was talk a little bit about that in that context. So after all, machine learning has been around for a long time. We were building neural networks 30 years ago. And perhaps 5 years ago, 4 years ago, technology and math conspired to create an ability to do very deep neural networks, literally from a couple of nets up to 20 or 30. And this would allow us to take a picture, and the first network would learn where the bits were, and the second one would learn where the lines were, and the third one would learn where the boundaries were, and the fourth would learn what the colors were, and the fifth would learn what the sizes of the objects were, and the fifth would learn their shapes, and the sixth would learn whether there were eyes in these shapes. And then eventually, a high enough level, what it would say is, we have a picture of a mother and a child. Right? And that development, which pioneered in machine vision, really has set the stage for an explosion that will come now for all of us. So you use computer vision all day if you use, for example, Google Photos or Google Images. And how does the computer know how to categorize the images that you give it? Well, it's been trained enough over and over again. It's seen enough pictures that when it sees a new one, it can do something which is called classification. It can say, that's a picture of a tank, or that's a picture of a monument, or that's a picture of a cat, or that's a picture of a child. It's uncanny how good that has become. And the same approach has been used to do machine translation. So if you take a look at the error rates that we have in Google Translate, which all of you use, we had an error rate of roughly 23%. We were able to reduce it to 8% using the latest deep neural networks. So we knew we were on to something. And from our perspective, we've now mobilized the entire company around machine learning. We have more than 100 teams using machine learning. And by the way, we use it to make your search answers better. We use it to make good YouTube recommendations. We use it to pick the thumbnail to show you when you have a YouTube video shown to you. Right? We don't just randomly pick one. We use history and an analysis from neural network machine learning to pick that. In innumerable small and very big ways, we use this technology to make your experience with Google better. And I will tell you, in my opinion, Google is the world leader in this technology. Partly because many of the world inventors now work at Google, because we hired them, and partly because we're putting so much emphasis, hundreds and hundreds of engineers, thousands and thousands of computers across our entire world. Now, you think well, how does this matter to me? Well, if you think about computer vision is better than humans. So why are you driving a car? Shouldn't the computer drive the car because it can see better than you can? And what about doctors? Wouldn't it be better for the computer to look at your skin, for example, or your x-ray and make a recommendation to the doctor? We think that those recommendations will be more accurate than human judgment, simply because of the number and the amounts of images that can be trained on. So these relatively simple steps lead to enormously interesting possibilities. And whether it's a question answering, our ability to answer emails, something that we announced last week, or game playing. We have a company that's part of Alphabet called DeepMind, which is busy learning how to play all the computer games in the world and beats them. But the way it learns is it's shown the bits. It's not given any other rules. It's not told exactly how to play the game. It understands the game, it studies the game, it figures out how the rules work, and it wins. And indeed, it's slowly marching past many of the computer games that all of you use. And I've seen the demonstrations, they're phenomenal, because remember, we didn't teach it the rules, it figured them out. We don't know how far this will go. It's a matter of speculation. something that you all will undoubtedly talk about among yourselves, but we do know that it will make Google much smarter, that Google's answers, the suggestions that we make, the daily life that you use, we are sure that this will make a significant improvement in the quality of the answers, suggestions, and services that Google gives you. I thought what I would do is just sort of finish with that, and I'd much prefer to take your questions or comments, Michael. Shall we just begin with with questions? Michael says yes. So I'm going to take the first question. This is from Jisun Lim, saying, when did Google start to put significant investments in machine learning? I can tell you that we started with a speech team that perhaps 7 or 8 years ago that did better speech, and we began to learn from there. Then we bought a company called DeepMinds maybe 2 years ago. We've been using this kind of learning in earlier forms for our ad targeting, and there were many good gains from that. But this technology really broke out in computer vision. And I would say that was 2 to 3 years ago, when we could all of a sudden begin to label whether there was, for example, a giraffe in the picture. We would do demonstrations where we would say, we'd look at all these pictures, and you type giraffe, and it would show all the thumbnails, even though the pictures weren't labeled as having a giraffe in them. You also see this, by the way, in face detection, which some of our products use. So I'd say roughly 3 years ago, 2 to 3 years ago was when it really scaled up. The next question we have is, why has Google open sourced our AI engine, TensorFlow? What is Google's vision about this machine learning in the near future? So for those of you, I think you have been briefed on this, we developed a library called TensorFlow. A little bit about how the math works in machine learning. The easiest way to understand it is it's multiplication of matrices, and it's multiplication of n-dimensional matrices, which are called tensors. And these matrices are relatively sparse. Now, this multiplication is something which is done over and over and over again to propagate or change the weights in these networks. So the way that knowledge is assembled is there are nodes that have numbers associated with them. And by this multiplication of matrices, right, those numbers change. And then when you present this matrix with an input, it will give you the correct output. That's roughly how the algorithms work. So TensorFlow is our attempt at building an open source network that does this. We released a version that runs on one computer so that people can use it for research. And more importantly, we released software which does the kind of classification. Now, why would we do this? Why would we release software that's so valuable? Because we gain if the industry gets smarter. This is so new that if we get everyone using TensorFlow, right, the smart people who are in universities and research labs all over the world, then we will get a benefit because they'll make it stronger and better, but we also benefit with just more knowledge, more discovery, and so forth. So Google has taken the very unusual step of taking one of its most core pieces of library, literally this library called TensorFlow, and we're releasing it. And I'll say with some confidence that it's so good that most AI groups, probably including our competitors, will start to use it. And I'm very, very proud of this. This is an example of how Google does unusual things. I have another question. This is from Junya Ishino in Japan. It says, what's the next problem to be solved in machine learning? Most of the interest right now is in reinforcement learning. And the way reinforcement learning works is that you generate some scenarios and then you cull the scenarios that aren't right against an objective function. We don't know how far that can go. We don't know how broadly applicable that looks like. We don't know what that objective function could look like. We also don't know how these algorithms can coexist with others. So today, if you speak to an AI researcher, they'll experiment with one, they'll experiment with other kinds of semantic understanding. We don't understand their interactions and so forth. It feels very early. It feels very much like we don't know the answers to these questions, and researchers are working very hard on this. Over the next few months, there are a set of conferences to debate these questions and to see what we can do. Our next question is from Karen Lee from Korea. She said, you said a computer is better than a human being at driving a car. How should the car be programmed? Is it possible for a computer operating a self-driving car to learn ethics as a machine? Well, let's think not the way programmers used to think, but the new way. So each of you is doing a startup around self-driving cars. And you have a brilliant programmer and you know how to do machine learning. What could you do? Well, the simplest way to learn would be to start driving cars. And if you drive enough cars enough times, the computer will learn that if there's a stop sign, you should stop. And if there's a turn left sign, you should turn left. And if there's an object in the road, you should stop. Now, much of the original self-driving car work was deterministic. That is, the algorithms were not using this kind of machine learning. But today, if you were to use a self-driving car to build a new one, you would undoubtedly do that. So in that sense, what you're doing is you're training a car to drive the way a human does. So the answer about ethics is really a question of, do you think the human ethics in car driving are correct? And I think in practice, you would do this for a while, but you probably put some other rules in just to make sure. You probably always stop at a stop sign rather than not just occasionally. And you would probably come to a full stop at a stop sign rather than what we in America call rolling stops. So there are probably some adjustments you would do, but you would start, I think, with training how humans really use the system. Our next question is, some people say we should stop using brain metaphors when we talk about computing since we have no idea how the brain works. What do you think? I think there are two completely separate paths, and there is a great deal of research on trying to understand how the brain actually works. I don't think that we will build human intelligence by having computers simulate the brain, partly because it's combinatorically too complicated. The neurons are too interconnected, and there are too many of them in the brain. So I think with understanding of how humans, for example, collect memory, they focus on things, and so forth, we can build better computer algorithms. An example I would offer is that in brain science, we know now that when you look at a scene, your brain already eliminates most of the stuff that isn't changed. And all you look for are the things that are changing, verbally and audibly. So that's a form of reinforcement learning. You're only focusing on the things that change. So that concept applied to computers helped us build better computer algorithms. But I don't think that AI will look just like a brain. I think it will be its own structure derived from some ideas from brain science. Another question. Jitsuka Chin asked, how close are we to machine learning? It's as good as what we saw in the sci-fi movies such as Minority Report. This is a matter of science fiction. And almost all of the science fiction movies have, at the end of the day, a bad robot and a good human being. I don't think that's likely, because I think humans are not going to build bad robots. Only movies are going to build them. That's my own view. And many people think that we're talking about robots in this conversation. This has nothing to do with robots. This has to do with services that are on the internet, about information that make you smarter. With respect to things like Minority Report, these are dramas set in the future. There are people in my industry who believe that in 15 or 20 years, we'll have the kind of computer intelligence that can rival human intelligence. but I'll give you a simple example. When people are asked what robot do they want, the number one robot that they want is a robot to clean the kitchen. They literally, that's what they say. They want a robot that cleans the kitchen. That robot, the one that puts the dishes away and cleans the counters and organizes the flowers and all the other things, turns out to be an incredibly difficult robot to build. So we are a long way from that kind of ability and intelligence, and I think it's a matter of science fiction. Next question, Lester Gio from Singapore asks, how long are we to image recognition and video, and what are the key challenges before we get there? I think we're there. The only issue is computation, because we can see images in still frames, and it should be possible to apply that to video pretty well. It's just a matter of algorithms and speed of computers, and those are getting faster. Michael Josh asks, the quality of answers and services that machine learning enables is dependent on how much data is collected. How does Google alleviate privacy concerns related to data collection? This is a deep and important topic. It has a little bit to do with machine learning, but mostly just about data. But we work very, very hard to keep people's data private and to give you control over it. So we have a product called Dashboard where you can control what Google keeps of you, and we work very hard to keep your data secure. We are upset that it appears that the US government, the Chinese governments, other governments over time have attacked computer companies without permission. We work very hard to keep your data protected using incredibly powerful encryption. And to my knowledge, the safest place and most private place to put your data is inside of Google. And I really believe that. Far safer than, for example, giving it to the government. Next question. Stuff TV asks, what is the end goal for machine learning? Is there even one? We're at the beginning of a phase that will go for 20 or 30 years. It's hard to know what the end goal will be. I'll tell you one researcher I spoke with, I asked him what his goal was, and he said he wanted to have a computer that could learn enough physics to write a physics paper. And I thought that's a pretty good goal, but that's very far from what we can do today. And I suspect you'll see goals like that, all about increasing human knowledge incredibly quickly. I believe in my lifetime these will be at least achievable or thought to be achievable. Next question, Ji-Yoon Lee from the Korean Herald asks, how do you deal with language issues in the region where most users prefer to use their own search engines over Google? Well, first place, I'm not sure I agree with that completely. We're doing pretty well in Korea, I should add. We do well enough and we have enough traffic in countries where we don't have majority market share that our ability to do translation is good enough that I think you'll be pleased at how it is, even if we're not the #1 most popular search engine, for example, in China and in Korea. The next question from Krishnan Sharma is, how much of machine learning can be achieved on device, or will most of it require offloading to the cloud? It looks to us like much of it is going to be on the cloud. And the reason is that these networks are big. It's possible that in the future, the networks will be made small enough that they can sit on device. But pretty much all of the examples that I used require a pretty powerful computer that's more powerful than the computer that you have in your hand right now. I would suspect that that will change, but right now, what I like to think of it is the supercomputer on your phone really is using 5,000 or 10,000 computers in the cloud over a fast network, and from your perspective, it's all on the phone, but it's really phone plus cloud. Next question is, what is the most impressive breakthrough you've seen with machine learning? What I have been most impressed with is Google Photos. And the reason is that I have 25,000 photos. I put them all in. It recognizes everybody. You can look for combinations of people. It will even categorize things. So for example, it discovered ice skating pictures, and it discovered pictures of ducks, and it discovered selfies. How did it know how to do that? And yet the researchers say, oh, that's easy, that's old. We've been doing that for a long time. But that's an example where it really changed my ability to enjoy my memories and my photographs. And my guess is that the next one is going to be this game playing, because the games that they're playing are games I can't figure out at all, and I'm a human being, and yet the computer can figure it out with no instruction and actually win, and I can't win them, let alone figure them out. So when a computer does something better than you can, you've got to say, wow. So that's where I think I'll see. Next question. What did I learn on my most recent trip to Asia? As you may know, I was in Korea a week and a half ago, and then in China last week. And in Korea, I spent most of my time on entrepreneurial issues. And I believe basically that the Korean economy has slowed down. And I believe that the solution for Korean economic growth is more investment in entrepreneurship, especially in this area. We had a meeting in Korea with entrepreneurs, which represented the use of machine learning in every interesting field. So I was very impressed with that. And in China, where we're negotiating with the government and doing other things, I was impressed by the scale and growth of China, and as I always am. And I think China is going to do well. There's a whole narrative that China is slowing, but it has a lot of growth ahead of it. There's still a great deal of potential in their economy. I can't say at the rate at which, but you get a sense that there's a lot more room to grow in China. Next question. How different is machine learning in terms of a skill set from regular programming? How can countries and companies in Asia prepare for this? One of the reasons that we're having this event is because there are very few programmers and computer scientists who understand any of this. This is the beginning of a completely new thing. And programmers, just like everybody else, don't like change. So when I was a programmer, I was very good at figuring out all the algorithms and writing them all down at the ripe age of 22. Today, I think I would try to figure out how to program a computer to learn something. Well, that's a completely different idea. And so I don't have the intuition of how to learn something that this next generation will have to. So I think it's quite different. I think it favors people who are mathematically gifted, as most programming does. And I see every reason to think that Asian programmers can do as well or better than American and European programmers. After all, the majority of the programming contest winners tend to be in Asia, so there's clearly talent there. The next question is, how will machine learning be used in public interest areas like health, medical, education? How can Google cooperate with nonprofits and third-party groups in this field? I can tell you that I've met with a number of startups that have said, we can build a business that will take medical information and predict outcomes. This technology is very good at predicting a sequence of things. So if you have 1, 2, 3, 4, 5, 6, 7, it can predict the next one quite accurately. That information is extremely useful in medical, at least in medical instrumentation, in medical diagnostics, in assisting doctors. So I would predict that our technology will be used by that, but the majority will not be by Google, but rather by people who are nonprofits who use our technology to do the right thing. I think it's going to be a very big business, and if I were starting a company, I would be very interested in focusing on that area because of the simple scale of that. There's so much money, there's so many demands, there's so many opportunities for efficiency in the healthcare system using machine learning. Let's take a couple more questions and then I'll wrap up. How has the creation of Alphabet changed the way that Google runs its businesses? Not very much. It's the same people, same sort of usual problems. I think that Alphabet will bring better discipline in the company because each of the new initiatives now has a CEO with a profit and loss, where we didn't have that before. But it's still Larry and Sergey, it's still the same senior leadership, but I think it will provide more focus. So what you'll see is faster products, more focused outcomes, and for investments, I would hope you'll see quicker progress toward profitability. Of course, it's only been around for a couple months and we're still working out the details, so we'll see. So let me answer your last question and then I'll make a final set of remarks. The last question is, what are the biggest challenges facing the internet right now? There's a long list of challenges. There are ones about security, and there's ones about globalization, and there are ones about what happens to the companies that want to go public, and then there's all sorts of questions about governance and all of that. But I think the greatest challenge of all is getting to every human being on the planet. We have on the order of 3 billion people using the internet in one form or another. That's not a majority of human beings. With the smartphone revolution, we can probably add another couple billion in the next 5 years, so perhaps we can get to 5. But the internet wasn't just designed for rich people, it was designed for everybody. And when I think of an incredibly poor person in one of the poorer developing countries, for example, in Asia and Africa or Latin America, when I think about that person, they would benefit so much more from the internet than I would. Because after all, they don't have a school system, or they don't have a police system that works. They don't have a way of making money. They don't have a bank. They don't have a camera. All right? But if we could get them inexpensive computational devices and at a bandwidth cost that they can afford, and remember, these are people who live on $1 a day, so it has to be far cheaper than it is today, then we will have made a huge contribution. Because I am clearly in the camp that the internet is overall a huge modernizing force, and that this modernizing force and the globalization that it represents means that the world will be healthier, happier, better for the men, better for the women, better for the children, fewer wars, all of those kinds of things, because of the benefit of connectivity and getting each and every person onto the internet. We've been celebrating the eradication of polio. Right? So everyone's very excited about eradicating a disease that has been a scourge for humanity for many decades, hundreds of years, excuse me. But we should also have a goal of getting everyone connected. And everyone means every single last person, not just most people. And I think that's the greatest challenge of us all. Michael, what I wanted to do is I wanted to finish by saying something that I wrote down to put this machine learning thing in context. What I actually think machine learning will do is make us behave less like machines, not more. I think when you look back in the 1950s, there was an awful lot of things that people did that we don't do anymore because they've been eliminated, whether it's repetitive things in the manufacturing line or huge pools of women typing and things like this. The world is just so much more efficient, so much more human-friendly today. So in 2050, when we look back, we'll say the same things. I mean, these computers, for all their power, have created this enormous amount of work for us. We spend so much time typing, right? How much time do you all, you're all journalists, every one of you spends all day, including at our seminar, typing. Why doesn't the computer just know what you want? Why can't it just listen? Why can't you just talk to it and make that happen? We spend a tremendous amount of time turning perfectly good information, like charts and photographs and words, into characters that machines can read them. And then we have an awful lot of time entering the characters and recognizing the characters, especially in Asian languages. And then we spend a ridiculous amount of time trying to remember a key phrase of an email whose attachment we can't find, right? We spend so much time combing through reports to find one chart. We shouldn't be doing any of that. So for me, the vision of what we're trying to do is to make that stuff human-friendly in the sense that it just shows up. It doesn't need to be searched and eradicated and all that, but that it's a natural experience. And we want Google to be the leader in that. We're about information, not just about search. And as search changes because of all this technology, we hope that we will continue to be the leader in all of that. I want to thank you all for doing this on a Tuesday morning, and thank you for listening to me from such a remote location. I'm in Washington, D.C., home of American politics, and I'd be happy to be in Tokyo instead. You guys take care. Thank you so much.